Hello everyone and welcome to Precalculus. This is section 10.8 on the graphs of polar equations. These are really fun to draw. I think you're going to like it. I did take a minute and label my graph here. You might want to go ahead and do the same. It'll make it a little bit easier. But we're going to start out the same way you would when you were graphing anything. We're going to make a table. So we're going to start with theta, and then r is going to be 4 sine theta. Now, the one thing that's different is that it does help a lot if you go in order and then connect the dots. So I'm going to start with the ones that I know. So 0. Sine of 0 is 0. So now I have 4 times 0, which is 0. So my first dot is going to go right there. And then pi 6, 4 times sine of pi 6 is 4 times a half, which is 2. So at pi 6, I'm going to go out to 2. And then at pi fourths, I have 4 times sine of pi fourths, which is 4 times the square root of 2 over 2, which is 2 square roots of 2. Now, there are a couple points that you might want to have just memorized. The square root of 2 is approximately 1.4. And then in a few minutes, the square root of 3 is going to be approximately 1.7, because obviously you can't graph the square root of 2 as a number, but if you convert it to a decimal, then 2 times 1.4 would be 2.8. This is approximately, but honestly, if it's 2.7 or 2.9, you're not going to graph it any differently anyway. So on the pi fourths line, I'm going to go out to 2.8. And then at pi thirds, I have 4 sine of pi thirds. Sine of pi thirds is the square root of 3 over 2, which is 2 square roots of 3. Remember, the square root of 3 is about 1.7, so I can say that this is about 3.4. So on the pi thirds line, I go out to about 3.4. I know some of you are like, are you kidding me? This is so tedious. There are some shortcuts, but it'll make more sense if we do the first one all out. So sine of pi halves is 1. 4 times 1 is 4. Okay, now here's the good news. You know all these angles, they're going to just repeat. So when I get to 2 pi thirds, sine of 2 pi thirds refers back to pi thirds. And since it's in quadrant 2, it's still positive. So it's still going to be positive 3.4. So I can go right back to that. So 2 pi thirds, 3.4. And similarly, 3 pi fourths in quadrant 2 is the same as pi fourths, only for sine. If this was cosine, then it would be negative. So pi fourths was 2.8, so I can just write 2.8 again. See how it's already going faster? 1, 2, and then 0.8. And then what's next? 5 pi 6. Again, it's going to be the same, which we got 2 before, and we're going to get 2 now. And then sine of pi is 0, and 4 times 0 is 0. So I'm right back here. So I'm going to actually stop and draw the first part of my graph. It should come out to be pretty circular, something like that. Isn't that great? All right, but you do have to keep going. So now I'm going to move. I know. Again, you're like, are you kidding me? But it's going to go fast. You'll see. So think about this. When I get to 7 pi 6, that should be the same as pi 6, right? Because pi 6 is the reference angle. But sine in quadrant 3 is negative. So it's going to be negative 2. And then what do we have next? 5 pi fourths. 5 pi fourths should be the same as pi fourths, but negative. 4 pi thirds should be the same as pi thirds, but negative. And so on. Now, I'm actually not going to continue, because if you start to graph these, you're going to see something really interesting. At 7 pi 6, I go to plot 2, but then I realize that it's negative 2. So I have to plot it over here. I've already plotted that point. And then 5 pi fourths, I would plot 2.8, but it's negative, so I'd plot it over here. I've already plotted that point. And then, of course, the same thing is going to happen with 3 pi or 4 pi thirds would be negative 3.4, but I put it over here because it's negative, and I've already plotted that point. And that's because this circle just repeats. So we actually don't need to draw the whole thing again. So really the bulk of the work was in this first section right here. And then once you got to that, it was pretty straightforward and easy. Now I am going to show you more shortcuts this period, but remember, if there's ever a time when you can't make the graph, just make the table, and that'll always work. So let's give you some pointers on how to do these a little faster. So first of all, whenever you see that sign is in the function, it's going to be symmetric with respect to the line pi halves. So ours was just now a circle. Here's the pi halves line. See how it was symmetric over that? Where if you have anything with cosine, then it's going to be symmetric with respect to the polar, which is the x-axis. So if this one had been a circle, it would have looked like this. Okay. The second thing I look for is trying to figure out what would make R a maximum and what would make R equal to 0. So on this one, instead of maybe plotting all the points, I might have said, well, if sine is 0, it's going to come out to be 0. So at 0 and pi, I know it's going to be right here. And the biggest that sine ever is at pi halves, because sine of pi halves is 1. That's its biggest number. So then I know that this is going to become as big as 4, because 4 times 1 is 4. So again, these are just little tips to give you a sense of how big it's going to be. But the most important thing is this chart. You definitely want to copy this chart onto your appendix. We have limacons, and we have rose curves and circles. We just did a circle, right? And something called lemniscates. And fortunately, you can know in advance which of these functions it's going to be just by looking at its equation. So notice that we had a circle, and a circle is just going to be a sine theta, or if it goes on the polar axis, a cosine theta. That's the one we started with. But if you see something sine theta plus another number, it's going to add either a little loop-de-loop or a little divot there, something like that. If there is a number, if it's a multiple angle, so maybe cosine of 2 theta or cosine of 3 theta, it's going to make these pretty rose curves. And if r is squared, then it's going to make a lemniscate. So you're going to want to write all these down, but you're also going to want to add, at least I think, you're going to want to add a row. This row is specifically showing you cosine. For some reason, they didn't take the time to do the extra row. But if they are sine, then it's going to flip them all, because remember, it needs to be on the pi halves axis instead. So this one would actually end up looking like this. And this one would end up looking like this. And this one would end up looking like this. These are not perfectly drawn. And then this one would end up looking like this. Okay, so be really careful. This entire row is cosine, and they would all be on the polar, on the pi halves axis if they were sine. Okay, and actually this is specifically positive sine, and this is positive cosine. Negative would flip all of these upside down and would flip all of these over. So we have nothing left to learn. We are just going to do examples. So if you would like to try one on your own, or as many as you can on your own, that would be great. But of course, I am going to do it for you. So first I look at this, and then I try and match it on my chart. So I see 3 plus 2 cosine theta. So I'm just going to go ahead and write that on this page. 3 plus 2 cosine theta. So I know I'm looking at a limacon, and I see that A is greater than 0 and B is greater than 0, but I need to know their ratio. So 3/2 is 1.5. That's between 1 and 2. So now I know that it's going to be this dimpled limacon. And since it's a cosine, it's actually going to look just like this. So that's great. Now I have a good idea of what it's going to look like before I even start. So how do I actually graph it? You're going to have to plot points. So you can go in order like last time, and I'm going to start at theta and r. So when at 0, so 3 plus 2 cosine of 0 is 3 plus 2 because cosine of 0 is 1, and that gives me 5. So I'm going to go all the way out to 5. And then now cosine isn't really very friendly to us at pi 6, right? Sine of pi 6 is 1/2, but cosine of pi 6 is the square root of 3/2. So I'm fine with your skipping to pi thirds. Then you can do 3 plus 2 times cosine of pi thirds is 1/2, and 3 plus 1 is 4. So I go up to the pi thirds line, and I go out to the 4. And then at pi halves, cosine of pi halves is 0, and then I'm down to 3. And hopefully this is looking like what you're expecting it to. Now I have to go into quadrant 2, but remember, quadrant 2 should repeat, but cosine is negative in quadrant 2. So I can use my same answers, but I can't just make the answer negative. I have to make the cosine negative. So cosine of 2 pi thirds is 3 plus 2 times negative 1/2. Do you see where the negative was? It's not that it's negative 4. It's that cosine of 2 pi thirds is negative 1/2. So this becomes 3 minus 1, which is 2. So 2 pi thirds is 2. And then I can go all the way to pi. Remember that cosine of pi is negative 1. And I get 1. So at pi, I'm going to be down here at 1. Now, because you know that cosine reflects over the polar axis, instead of plotting all the rest of the points, look, I only ended up plotting 1, 2, 3, 4, 5 points. Instead of making more table, you could just reflect. So this one is going to go right here. And then at the pi halves, the 3 pi halves. And then at the pi thirds, the 5 pi thirds. And now you should be able to draw it. And that is our dimpled limacon. So our next one, number 2, is going to be r is equal to 1 minus 2 sine theta. So I started my chart, and I realized that it's going to be a limacon again, although careful, it's going to be sine, which is the row that your book for some reason didn't choose to show you. So we're going to use this extra row up here. I still am going to look at my A and my B, not the negative part. You're assuming that A is greater than 0 and B is greater than 0 to decide which of the 4 it is. But since that's less than 1, now I know I'm going to be doing the limacon with the inner loop. And I know I'm going to be doing sine. But in addition to that, you can only have so many rows on your table. It's negative. It's 1 minus 2 sine theta. So I think it's going to be an inner loop that's down. So it's going to have something that looks a little bit more like that. That was really poorly drawn. But that's what we're going to be looking for. All right. Now, these are going to require a few more points. I know we did this one in just 5 points, but you're really not going to be able to manage that with the inner loop because the loop is so tiny, you need lots of little points. So this is probably going to be your hardest one. R is equal to 1 minus 2 sine theta. So be a little patient with yourself. So 0, R is 1 minus 2 times 0, which is 1. So I'm going to start there. And then at pi 6, 1 minus 2 sine of pi 6 is 1/2. So 1 minus 1 is 0. So I need to get from here to here, but it's going to be some kind of loop. It's either going to do that or it's going to do that. It's not going to do it in a straight line. So if you want to, you can always remember that you're starting there. That's going to be spot number 1. And even though it's not going to be a nice number, last time I skipped pi fourths, but remember with the inner loop, you'll have to do it. 1 minus 2 sine of pi fourths is the square root of 2 over 2. This cancels. Remember, the square root of 2 is approximately 1.4. So 1 minus 1.4 is negative 0.4. I know you can't graph that exactly, just halfway is fine. But it's negative. So on the pi 6 line, I'm actually going to go over here to 0.4. And can you start to see? So now I do know that it's going to do this. And I can already start to see my inner loop forming. Okay, it's going to end up looking like that. So I go to pi thirds, which is 1 minus 2 times the square root of 3 over 2. Again, the 2's cancel. 1 minus the square root of 3 is approximately 1.7. 1 minus 1.7 is negative 0.7. So again, I'm on the pi thirds line, but I have to go opposite side because it's negative. And then this is what's going to make the most sense. Pi halves, 1 minus 2 times 1 is negative 1. So at pi halves, I'm down at negative 1. You see that inner loop there? And if you've understood that and you know it reflects over the y, which is called the pi halves, reflects over pi halves, you can actually, without making your table, you can duplicate these points. So now at the 5 pi thirds line, it's negative 0.7. And then at the 7 pi fourths line, it's going to be negative 0.4. And then it's going to go back to 0 at 11 pi 6. So it got all the way back to 0, which took care of quadrant 2, right? So if I do quadrant 2, I could just reflect. So after quadrant 2 comes pi, and we have 1 minus 2 sine of pi. Sine of pi is just 0, so we're back to 1 again. And like I said, I keep plotting as I go. It's much easier. So remember, I've come around like this, and now I'm going to get to pi is 1, and that gives me that other part of the loop, which I'm feeling really good about how it looks based on what I know it was going to look like. All right, let's do quadrant 3. So in quadrant 3, I'm going to go to 7 pi 6, which is 1 minus 2 times negative 1/2. Sine is negative. You thought all this was over, didn't you? Back in chapter 5 or something. But you still have to know it. So in quadrant 3, sine is negative. So this becomes, you still cancel 1 plus 1, which is 2. So at 7 pi 6, it's going to be 2. And if you want, you can go ahead and start reflecting now. So that one's going to be over there. But make sure you still go in order. And then we have, actually, now I think you can skip. So these next two, these 5 pi fourths and 4 pi thirds are not going to have the best answers. So I would be willing to let you skip that and go straight to 3 pi halves because you know what the shape is going to be. So 1 minus 2 times sine of 3 pi halves is negative 1, and then 1 plus 2 is 3. So if you think you can make a good shape, you really don't need these other points. I did them up here because I was trying to make that inner loop and it was very tiny. But down here, I'm just making the rest of this circle. So again, you go in order. I go to 7 pi 6, then 3 pi halves. Or maybe I can't do it. Look at that, was terrible. You do have to do a pretty good job. Otherwise, you have to do more points. There. And that's my limacon with my inner loop. So that was probably, in my opinion, the hardest one that we'll do. I think the rest of them you'll really actually enjoy. Number 3. So you can go back and look at your chart. 2 cosine 3 theta. 2 cosine 3 theta. So I look at my chart and I see that it's going to be a rose curve with a cosine. So it's one of these two. And this is the one for even and this is the one for odd. Mine's odd, so I'm going to use this one. So I know it's going to have an odd number of petals, and it's going to be symmetric over the polar axis, like all cosine functions are. But it's going to be odd, so it's going to have one up here and one down there, and this one's just symmetric kind of on itself. And then this number tells you how long the rose petal is. So this is fantastic. I can practically draw it right away. I know it's going to have a length of 2, and I know it's going to go up in this direction and this direction. So you pretty much want to take the whole circle, which is 2 pi, and you want to divide it into 3 petals. So 2 pi thirds is right here. And then the other third would be 4 pi thirds. Now you do have to plot one extra point. Plot one extra point for width. I mean, if you do this much, you're going to get a lot of points, but is it a big fat petal? Is it a super skinny petal? Is it a medium petal? They look different, right? So you definitely have to plot one extra point. So it's cosine, so you want to think of the easiest point you can think of. So I'm thinking pi thirds. So I do r is equal to 2 cosine of 3. Oh, but then there's a 3 in front of it. So look what happened. When you do 3 with pi thirds, you end up doing cosine of pi, and cosine of pi is 0. So actually, at pi thirds, that must be where it comes back down to 0. So it's going to make your loop, and that's where it comes back down to 0. So you're going to have to work a little bit harder to think of what kind of number would be easy to plug in here. So ironically, I would do pi twelfths. I know that sounds really crazy, but watch what happens if I do that. 3 times pi twelfths will have this, I know we never use that line, right? That's this one right here. 3 times pi twelfths will change this to 2 cosine of pi fourths, which is 2 times the square root of 2 over 2. These cancel, and it's just 1.4. So on the pi 12th line, I go out to 1.4. And that 1 point gives me all the points that I need because I can reflect. And that's how wide the petal is. I can do that over here also, 1.4. That's how wide the petal is. And I can do it again over here. So I'm really making a lot of use out of that one extra point. Okay, and that's my rose curve. So this is going to be your hard part. I mean, you'll know right away. If you pick a bad point, you'll be like, oh, that didn't help me. So you got to kind of think ahead to pick a point that actually is going to help you. All right, r squared. So I'm sorry I keep going back and forth. 9 sine 2 theta. I'm trying to memorize that. 9 sine 2 theta. So this next one is going to be 9 sine 2 theta, r squared. This was my equation. So I know it's going to be a lemniscate. And because it's a sine, it's going to be going at a 45-degree angle. If it was a cosine, it'd be lying down flat. The A is this distance right here. So I know that the length of it is going to be 3. So like the last one, you're almost going to have it drawn without doing hardly anything. I know it's here. I know it goes out to 3 in both directions. What's the only thing that I need? How fat it is. Okay, is it like a skinny little flower or is it big? So most people don't like trying to figure this out, but it's the same thing as before. If you want to do sine of, say, pi 6, then you're actually going to want to start with sine of pi 12ths. You see how that's going to work out for you? So r squared is equal to 9 times, this reduces to pi 6, and sine of pi 6 is 1/2. Now, unfortunately, these still are not very nice. So we have 9/2, which is 4.5. But you still have to take the square root of that. So r is equal to the square root of 4.5. I know you can't graph that, but the square root of 4 is 2, so it's just a little bigger than 2. So on the pi/12ths line, I'm going to go a little bigger than 2. Now, see, I find that very interesting because that means it's really a pretty fat petal. You see what I mean? If it had been down here at 1, it would have been a lot skinnier. And then I do the same thing on the other side, something bigger than 2. Oop, on the pi/12ths line. So again, you can get a lot out of the shape, but you still need that one extra point to give it its width. Okay. All right. R cosecant. So this is a little, this is nowhere on our chart. So I really want to change it to sine, which means this is going to be 5 over sine of theta. And then I'm going to multiply both sides by sine to clear my fraction. And I get r sine theta is equal to 5. I go back and I look at my chart. These are all r is equal to, right? I don't see anywhere it's r is in there, even on these down here. So this one is different. This one, do you remember this from section 10.7? This is y. So this is literally the equation y is equal to 5. It's actually going to just be a line. So I go up to y is equal to 5, and I make a line straight across. Okay. So a little bit of a reminder there from section 10.7 on how to finish those out. Number 6, r is equal to -4 sine theta. So again, I go back to my chart. Sorry, back and forth, back and forth. And I look for it. I see it right here. It says -4 sine theta. So I know that my A is going to be 4, but because it's negative, I'm predicting that my circle will be underneath instead of on top. So I go back. I feel like I know what it's going to look like. I think to myself, it's going to look like this, but I still always plot some points. So I make my table, theta, and then -4 sine theta. So I start with 0. Sine of 0 is 0. Pi/6, -4. Sine of pi/6 is 1/2 is -2. I'm going to try to get away with not doing pi/3 or pi/4, and I'm going to try skipping to pi/2 and seeing if I can see the shape. So pi/2 is 1, so I get -4. Always plot them in order. You're starting at 0, and then you're going to -2. So on the pi/6 line, I'm actually going to go backwards to -2. And then at pi/2, I'm going to go to -4. Is that enough to make a circle? If you're a good drawer, that is definitely enough to make a circle. I do not need, I don't think, these points in the middle to be accurate. But I know it's going to come back up, so I can reflect this, which is going to be right there. And then I can come back up and I can have my circle only plotting 3 points and using the chart. The chart is everything. So speaking of the chart, here I go again. Back to the chart. And now I'm looking for, I'm actually just going to clear this out. R is equal to 2 times 1 plus 2 sine theta. That's not on here. So you have to just multiply it out. 2 plus 4 sine theta. Now I realize that it is going to be a limacon. It's going to be sine. So it's not going to be one of these. It's going to be one of the ones that's on the pi/2 axis. But it's 2 over 4, which is less than 1. Why did I give this one to you? Because I want to see if you can do another inner loop. So this is one of the really challenging ones. That's why I put 2 of them in your notes. If you were in school, of course, I wouldn't even still be teaching. I would just be walking around. So let's change this to 2 plus 4 sine theta. You know it's a positive and it's sine, so it's going to look like this. with the inner loop. Let's go ahead and start plotting some points. Remember, this is the hard one. So theta and r. I'm going to start with 0, which will give me 2 plus 4 times 0, which is 2. So at 0, I'm going to start at 2. At pi 6, I'm going to do 2 plus 4 times a half, which is going to give me 2 plus 2 is 4. So at pi 6, this is going to go all the way out to 4. Then I'm going to see if I can get away with, because this is clearly making the big part of the loop, not the little inner circle. So I'm going to skip all the way to pi halves. So pi halves is 2 plus 4 times 1 is equal to 6. It goes all the way up to 6. So I guess I didn't quite make it there. 6. And then it'll repeat for 5 pi 6, right? They should be the same because sign is positive in this middle part. Remember, not necessarily the same answer, but the same right there. So I do get 4. So 4 is right there. And then when I get to pi, sine of pi is 0. So 2 plus 4 times 0 is 2. All right, now it's where it's going to get a little tricky because you've gone up and around, and what it's going to do is it's going to come down, and then it's going to make a little inner loop. So this is where you need to pay a little bit more attention. So I go to 7 pi 6. 7 pi 6 is going to be 2 plus 4 times negative 1/2. Sine is negative in quadrant 3. So that's going to be 2 minus 2, which is 0. So at 7 pi 6, it's going to reach that 0. So it's come up like this. It's gone around. Oh, I can't have that. That was so bad. And then it reaches at 0. So what do I expect it to do now? To make its loop. So when I do this, now I really feel like you need to have a few smaller points. So I'm going to do 5 pi thirds, or 5 pi fourths, which will give me 2 plus 4 times negative square root of 2 over 2. These cancel, and I get negative 2 square roots of 2, which is 2. Instead of 1.4, it's going to be 2.8. So the square root of 2, remember, is 1.4. So 2 square roots of 2 is going to be 2.8, which this is a nice, easy subtraction. So at the 5 pi fourths line, I'm actually going to go to negative 0.8, which just means I'm putting it on the other side. All right, so I did one of them. I got enough of the little point. I'm going to go all the way to 3 pi halves now. So at 3 pi halves, I get negative 1. So 2 plus 4 times negative 1 is 2 minus 4 is negative 2. So at 3 pi halves instead of 2, I'm going to go all the way up to negative 2. So I see that, and that looks very skinny. So maybe I should have done one more with the pi thirds. I don't want you to make it too shallow. But on the other side, it's also going to have a 0.8. I can see why, because I did that more to like a half. You definitely want it to look right. So 0.8, and then 0.8 on the other side, and then the 2. I mean, it's kind of skinny, but, and then you can just round that out like that. So it's tricky, right? This one with the inner loop is something that you'll have to really take some practice on. But knowing which picture it's going to be in the beginning is really important. All the time, I see people who are just looking at the chart quickly, and they're literally trying to make these points fit on the sideways loop because they didn't realize that it was sine instead of cosine. So just be careful. All right, there are How many? 5 more to practice on, plenty more to practice on if you want to stop watching this video and try them on your own. But of course, I am going to do them for you. So this time, this is going to be another rose curve. I know that my petal length is going to be 4, and this time this is even. So if you go back and you look at your chart, it says that if n is even, then you're actually going to have twice as many petals. So if n is 4, you have 8 petals. It says it right here, 2n if n is even. So I know that this is actually going to make, instead of 2 petals, 4 petals. So that chart is everything. And it's cosine, so it's going to be symmetric on the x-axis. And a is equal to 4. So I literally have my 4 petals already. What do I just need? I just need a point. I really would like to do pi thirds because pi thirds is so easy, but it's going to get multiplied by 2. So ironically, I'm going to do pi 6. I'm going to plug in pi 6 because when I choose to plug in pi 6, the 2 and the 6 will cancel, and I actually will get to do pi thirds. Cosine of pi thirds is 1/2. 4 times 1/2 is 2. So not at pi thirds, but at pi 6, that's what I ended up plugging in. It comes out to be 2. So here's my pi 6 line, and it's 2. I can use that for every single petal. So go to pi 6 for all of them and put it out at, oh, that's not 2, that's 3. Okay, and put it out at 2. Maybe I should stop and draw them first. So because those dots go with that one, and then this one goes with this one. And then again, I go down to the 2 and, oh, way out here, pi 6 line. See, I started drawing the pi 12th, and I realized that was too narrow. And then the pi 6 line again. And there you go. That's my rose curve. All right, another super weird one. So I'm going to clear the fraction first. You'll see on your chart there's no fractions like that. So I multiply both sides by 2 sine theta minus 3 cosine theta. And of course, on this side, it cancels. And then on this side, I'm going to distribute that r so that I get 2r sine theta minus 3r cosine theta is equal to 6. And this is just another one of those tricky ones. This is equal to y, and this is equal to x. So I can rewrite this as 2y minus 3x is equal to 6. This isn't on the chart because you do not want to graph that as a polar function. It's so much easier to convert it to rectangular coordinates. Of course, now the question is, how do I graph that? So I get y all by itself. 2y is equal to 3x plus 6. Y is equal to 3 halves x plus 3. So it has a y-intercept of 3, and then it goes up 3 and over 2. So how do I graph that? Well, you can still use these lines, 1, 2, 3, 1, 2. So it's not perfect, but it's going to look something like that. I didn't go up 3 and over 2 because I couldn't really quite go up 3, so I went down 3 and then back 2. And I could have done it again, but it gets a little harder to see it. But this would be 1, 2, 3. It's almost like you have to draw. Kind of did on 10.7. You might remember that I drew those lines on there. And then this one and this one. So down 3 and oh, okay, it was actually turned out to be spot on. So, but you could draw little lines on there if you needed to. All right, number 10. You know what this is, right? This is another one of those limesons. But this is cosine for the first time, so it is going to reflect over the polar axis. And it's 2 over 3, which is less than 1, which means it's going to have an inner loop, but it is negative. So if you look at your chart is going to show you a picture of this. The chart always shows the positive. But since ours is negative, it's actually going to look something like this. So this is what we're looking for, and that's going to help a lot if you can picture it in advance. So let's go ahead and find some points here. So I'm going to start with 0. 2 minus 3 cosine of 0 is 1. I'm at -1. And I'm going to see if we can do this by skipping pi 6 and pi 4ths, which are not going to have nice answers, and skip all the way to pi 3rds. That's going to give me 2 minus 3 times cosine of pi 3rds is 1/2, which gives me 2 minus 3/2, which is, so you can see where I was going, 4/2 minus 3/2 is 1/2. So at pi 3rds, right there on that line, it's only going to be 1/2. All right, and then at pi halves, 2 minus 3 times 0 is 2. Now you have to remember this is a very fluid shape. We have to connect these dots. This is dot 1, dot 2, dot 3. So somehow I need to connect them so I have a sense of it's probably curving like that. But of course, let me just take those away. But we're just going to keep making points until we figure it out. So then 2 pi 3rds is 2 minus 3 times -1/2, which is 2 plus 1/2, which is 3/2. So I'm at 2, and now at 2 pi 3rds, I'm at 3/2. And then at pi, cosine of pi is -1, which is going to put me at 5. So I'm all the way here at 5. So now I definitely feel like I have a good sense of its curviness. And now I can reflect. I don't actually need to fill out this table. If that's 2 pi 3rds, then down here at 4 pi 3rds, it's also going to be 3/2. And then at 3 pi halves, it should be 2. And then this is pi 3rds, so at 5 pi 3rds, it should be 1/2. And then it's going to just circle back. So the more you practice these, the more you'll have a really good sense of what they look like, even difficult ones like the inner loop. But if you have trouble with it and you don't take the time to analyze it first, you're going to be plotting a lot of points and maybe still getting it wrong. Number 11, this is going to be another rose curve. It has 3 petals. It does not get doubled because this is odd. So there's actually going to be 3 petals. And each one is going to have a length of 3. So we did this one almost exactly before. It's going to go out to 1, 2, 3. And I need to break down this entire 2 pi into 3 petals evenly distributed. So I divide by 3, and that tells me how far apart they are. So one's going to be at 2 pi 3rds. If I add another 2 pi 3rds, I'll get 4 pi 3rds. If I add another 2 pi 3rds, I'll get 6 pi 3rds, which of course is 2 pi. So here's my 2 pi one. Here's my 2 pi 3rds. Here's my 4 pi 3rds. 1, 2, 3. And I have my petals. But you must find the width of the petals. So I pick one good point. So for me, I might have told you last time that, I think last time we might have picked pi 12ths because that made pi 4ths. Can I do anything better? I don't think so. I think pi 12ths is going to be my best bet. Because if I pick pi 6, this will switch to pi halves, and cosine of pi halves is 0. And if I pick pi 3rds, it'll come out to pi. Yeah, I think pi 12ths is my only choice. So 3 cosine 3 theta, 3 cosine of pi 4ths. I multiply 3 by that theta, which is 3 times square root of 2 over 2. This is definitely not easy. So square root of 2 is 1.4. So 3 times, oh, I remember last time it was a 4, so it was pretty easy, but now it's a 3, and it's definitely a little bit harder. So the other thing you might want to know is that the square root of 2 over 2 is 0.7. You can put that in your notes because 1.4 divided by 2 is 0.7. And now it's not so bad. 3 times 0.7 is 2.1. So how wide is my pedal on the pi 12th line? I'm going to put it, oh, way down there. At, oh, no, not 0.7. At 2.1. I was going to say that looked wrong. 2.1. And then I can put it on the other side too. Looks like that. And then same thing over here. 2.1. And now I can make that pedal. And then 2.1. All right, you're almost there. We just have one more. If you haven't stopped and tried one on your own, you really should do that. This is going to be a lemniscate because you see the r squared. That always tells you that it's a lemniscate. And it's cosine, so now I know it's going to go this way instead of on a 45-degree angle. This tells me the pedal length. So the pedal length is going to be equal to 2, not 4. If you look back at your chart, it says that this is a squared. So a is just going to be 2. So I just have to go out to 2. Now, you could just go ahead and draw this, and I will give you half the points because that was pretty straightforward. Instead, I really want you to find the width of each pedal. So I just need one good point. So r squared is equal to, theta is equal to r squared is equal to 4 cosine 2 theta. So which one should I pick? I'm going to pick pi 6, because if I pick pi 6, then when I multiply it by 2, 4 cosine of 2 times pi 6, that becomes 4 cosine of pi thirds. 4 cosine of pi thirds is 4 times 1/2, which is 2. But remember, that gave me r squared. So r squared is 2, but r is equal to the square root of 2, which for the 100th time today is 1.4. So where were we? We were on pi 6. So on the pi 6 line, it's 1.4. And I can do that on both sides. And that's how big it is. And I can do it on the other side too. I don't have to find a new point. And there's my little lemniscate. All right. I think these are really pretty, really fun. Definitely a little bit of work, but I gave you 12 examples. I'm hoping that that was enough that you understand it. So have a great day.